How's it going, everybody? And welcome back to our Cisco Enterprise series. We're going to pick up where we left off at the end of last video, where we had just gotten all of the eBGP peerings and a full mesh design here, and then a route reflected design here. What we're going to do now is we're going to focus on doing all of our eBGP peers. We don't have as many to do. We have 1, 2, 3, 4, 5, 6 to get deployed, so it's going to be pretty quick. But I'm not exactly sure how I'm going to do it. My intention is to do something like this particular. So R26 on R33 will do a provider independent route advertisement, meaning that R33 will advertise its subnet into BGP, and then XR42 will do a provider aggregated design where XR42 will advertise this subnet right here, 134.42, into BGP on behalf of the customer, so you guys can see how both of those go. And that will help us dive into next hop processing, and then what we will need to do in order to figure out how to get traffic from point A to point B. The intention is to go through and have R33 be able to ping R22 by the time we're done, and it's to get data plane reachability over the internet. So the order in which I'm recording these videos is not linear, so I'm not recording all of the protocol independent routing, then all of OSPF, then eIGRP, then BGP. I am doing it in chunks, so I can get certain things working to do demonstrations on different things. So the videos will be ordered in which you can go through the individual block of OSPF, BGP, eIGRP, what have you, but the way that they're actually being recorded is so that I can do specific demonstrations. With that being said, I'm going to start off between the two different providers, 27 and 43, and we're going to go through that. Actually, I'll start off on 60 and 28 first, and then I'll do 43 and 27 because there's a specific thing I need to cover on XR when it comes to that with route policies. So with that being said, let's go ahead and jump over here to R60. And I'm going to go to global config and router BGP1. Now, just like an eBGP peering, the configuration to do an eBGP peering is the exact same thing. The only difference is a different autonomous system number. So I'm going to type in neighbor 12.28.60.28 remote AS of 2. And then I'll type in address family IPv4 unicast, and then I'll activate the peering. And that is it. I'll go over to 28, I'll do the exact same thing. Show run section BGP. We'll go up to router BGP2, neighbor of 12.28.60.60, remote AS of 1, and then address family IPv4. We're going to go ahead and activate that peering. So once the BGP routes propagate, we'll be in pretty good shape. Or I'm sorry, once the BGP peering comes online, we'll be in good shape. So again, we're not advertising any routes. We're just setting up the control plane. So do show IP BGP summary, and we're going to have one eBGP peering right there. Okay, so I'm going to go to 27 and do the config on that side. Do show run section BGP just to check the config. So this is the non-address family specific config. So I'm going to type in router BGP1 and type in neighbor 12.27.43.43 remote AS of 2. And then on XR43, we'll log in with Rob and Cisco. Go to global config, router BGP2. And I'm going to say neighbor 12.27.43.27 remote AS of 1, address family IPv4 unicast, and then I'm going to go ahead and commit that config. And the config took correctly, but you do show BGP IPv4 unicast sum. Okay, so this is what I was wanting you guys to see. Now iOS, and iOS XE and Nexus will automatically form a BGP peering externally without any additional caveats. iOS XR, on the other hand, is a service provider-based platform and does have an additional step that you need to go through in order to do route exchange via eBGP. And the idea is this. The peering itself is actually up, right? We can see that right here. However, you'll notice that right here, we have this, if I hit the up arrow again, you have this, it's up, but you notice this exclamation point at the end. So it says right here that some configured eBGP neighbors under default or non-default VRFs do not have both inbound and outbound policies configured for IPv4 unicast address family. These neighbors will default to sending and or receiving no routes and are marked with the exclamation point in the output below. So what's missing on XR is a route policy that is explicitly, not implicitly, explicitly permits route propagation between XR43 and R27. So to fix that, I had to go create what they call a routing policy, or an RPL. So it's going to be route policy, and I'm going to call this eBGP. I'll just call it eBGP. And then underneath here, I have a couple of options. And what I need to do is I need to type in the command pass, and then type in exit, and then commit. So if I show run section or begin routing policy, or that might be RPL, route policy, right here. So I have this route policy that's been created. So what I need to do is for that peering, this one right here, I need to associate a route policy underneath the address family IPv4 unicast address family. So router BGP2, and then underneath the neighbor, this guy, I'm going to type in route-policy eBGP in and out. I'm going to go ahead and commit that config, and then do show BGP IPv4 unicast summary, and now the exclamation point goes away because now the BGP peering has an RPL attached to it that allows the exchanging of routes both inbound and outbound. Okay, so I'm going to go ahead and do the same thing for, I'm going to do it on R26. So on R26, I'm going to form a peering with R33, even though on R30, even though over in the HQ site, I really don't have an AS number assigned. I'm going to just go ahead and use 65,001 for simplicity purposes, and then we'll go from there. So I'm going to bring this guy back over, pull up the CLI again, and on 26, I'm going to go over here, type in router BGP1 neighbor of 1.26.33.33, remote AS of 65,001, do show run pipe section BGP, address family IPv4, the unicast. Oh, the neighbor statement automatically applied. So, and then we're going to have to, oh, that's right, because I have, we should be good to go there. Okay, cool. So I'm going to go over here to 33. I actually have to open up 33 in Secure CRT, just like that. And I'll bring him down to here. Technically, these guys need to go before. Just like that. Now on 33, this router is blank. So I'm going to type in host name is going to be R33. I'm going to go to, I haven't configured him at all yet. So we're going to go to interface gig 0/1. IP address here will be 1.26.33.20 or 33/24. I'm going to no shut that interface. and I'm going to save that config, just in case something was to go down, lose power to the lab, what have you. I'm going to type in router BGP 65001, and we're going to assume for the moment that this is a customer that we're peering with, and this customer needs to do a BGP peering with us. They own their own address space, they own their own, but they don't have their own autonomous system number, and they are, I'll say they have a CCNA level of understanding with BGP. So they want to do a BGP peering with us, but they have asked us to do, there's a caveat I'll talk about here in just a moment. They don't have their own public autonomous system number, but they do have their own public address space. Typically, you'd get one and the same, but for this scenario, they got halfway through it and they never got their autonomous system number. So there are ways to handle that to where by default a private AS range is not allowed on the public internet as a BGP route. So the private ASNs are not allowed in the BGP AS path. So what the provider could do is on R26's side is you can tack on the command remove private AS from the AS path and advertise it as being propagated by AS1. We'll see that when we go to actually advertise a route, which we're going to do here in just a minute. So I'm going to go ahead and type in neighbor of 1.26.33.26, remote AS is 1. So that's literally as far as I'm going to take it, because remember, this is a CCNA level of understanding to do all the configuration. We're going to wait for that period to come online. There it is. So now we've got that done. The next thing I'm going to go do is, again, CCNA level of understanding, we're going to do a very basic configuration. We're going to type in network of 1.26.33.0. And when you're doing your configuration here, if you don't specify a mask with BGP, what will end up happening is it will default to the classful range. So if I hit the enter key and I go over here to 26 and I do a show BGP IPv4 unicast, nothing's coming through yet, right? So if I do a summary, I would expect to see something coming across. Let's see here. 33. So I've advertised the route. Do show IPBGP. And you'll notice that the route advertisement do show run section BGP. Okay, it's been applied, but you notice nothing's happening with it. Now, the interesting thing about this is when you do this, it's just a best practice to throw in the mask command so that it's a classful range. So we'll just do a /24 because that's what matches on it. Now if I do show IPBGP, now we'll see that route in the local table. And we'll talk a little bit about how the outcome comes here, but on 26, if I hit the up arrow, we'll start to see a route come across. And if I do show IPBGP unicast, we'll see that it's 126.33.0/24. The next hop is 126.33.33. Now, everything's a full mesh. So if we look at 27, right? If I do show BGP IPv4 unicast, you'll see that 33 comes across, right? So 27 sees the route 126.33.33, but notice the next hop that's attached to it is 1.26.33.33. Now, at the control plane perspective, it's propagating the route. If I go to let's say I go to 43, and I hit the up arrow, I see routes coming from 28, right? And I see a route coming from 27. It's going to be the same prefix, right? Now, from an eBGP perspective, I see it coming from the correct next hop. I see it coming from the eBGP next hop because that's how eBGP works. But if I go to 60, I do a show BGP IPv4 unicast, you'll notice that the route, I still get the next hop of 126.33.33. And this goes back to what I was talking about previously when it comes to next hop recursion, where if the route from a control plane perspective, BGP will propagate the route. It doesn't have any underlying visibility of how to get there. So what ends up happening here, if I go over to say 61 and I do a show IP BGP, because it's going to be the same output, you'll notice that the route, I'm missing something here. There's supposed to be a best, I have the star, meaning it's a valid route, right? But then I'm missing right here. In between the star and the I is supposed to be this caret that says it's a best route. And the reason why it's not showing up is if I was coming here and do 1.26.33.0, it says it's inaccessible. It doesn't know, from a forwarding perspective, how do I reach 12.27.43.27? 61 has no idea what that IP address is. But that, from a BGP perspective, that's the next hop, right? That's who advertised. So 27 advertised it to 43, 60 advertised it to 28, but you notice those are the IP addresses. So control plane wise, the routes do propagate. So control plane propagation does not mean the same thing as data plane reachability. Two completely separate things. Now I'm going to continue on, and I'm going to show you guys how to fix this here in just a minute. But it's very, very straightforward understanding. This is, again, this is inaccessible as the, I think I said unreachable. I meant to say inaccessible. But the reason why it shows up that way, let me go back over here to 60. If I was to look at this in 1.26.33.0, it has a metric to it, right? But R60, if I was to do a show IP route for 1.26.33.33, it does have an OSP route to it, which is why it's able to install it in the routing table. But again, this is where one of the caveats that comes into play with where we're trying to go. So the question is, will I be able to ping 126.33.33 from here? So let's try to ping it. Ping 1.26.33.33. How come I can't? How come I'm not able to reach that? Let's go over to say 33. What does 33 see? Do show IP route. Well, 33 doesn't have any routes either. So there's a couple different things that you have to keep in the back of your mind when it comes in terms of propagation. In this case here, 33 doesn't have a route to anything. He literally just has a peering, and all he's done is advertise his local subnet out. So there's still more work to be done, right? So there's a couple different steps to it. As long as everybody has either advertised their subnets one way or the other, whether it's local network statements or they've redistributed connected into BGP in order to propagate the routes, you got to do route propagation one way or another. So if they've done either done a network statement to advertise the routes that they locally own into BGP, or they've done a redistribute connected in iOS and XR into BGP in order to get locally attached subnets that BGP actively owns to go into BGP, you're not going to get any route advertisement. So let's continue on getting these other BGP peerings online, and we'll continue to do some aggregation. What I'm going to do is on XR42, since I'm already here, I'm going to log into here, and I'm going to go to global config, router BGP1, and underneath address family IPv4 unicast, I am going to propagate on R33's on behalf of R34 right here. I'm going to go ahead and advertise this 134.42 into BGP. So I'm going to type in network 1.34.42.0/24. I'm going to go ahead and I'm going to commit that config. Do show run pipe begin router BGP. And we can see we have a subnet in the BGP table. Now if I go over to 27 and hit the up arrow, it is going to take a moment for that to propagate. So if I jump out of global config and I type in debug BGP IPv4 unicast updates, once that has a moment to propagate, we should be okay. Now, if I go back to XR42 and I do show BGP IPv4 unicast, we have, well, it's not even advertising. So do show IP interface brief. That is a subnet that we own. Show BGP IPv4 unicast. Why is that not coming across? Show run router BGP. Show run interface gig 03. Oh, doesn't do show IP interface brief. 2642. Did I seriously not configure it? I did not configure it. Way to go, Rob. So interface gig 000003. IP address here is going to be 1.34.42.42/24. No shut. Commit. So, and you have problems like that every once in a while. So don't be like Rob and forget to configure an interface. So 27 gets an update, and if we do a show BGP IPv4 unicast, now we can see the route coming across, but now you see it coming from the next hop of 42. So depending on how the route is advertised will also dictate how the next hop is processed. So if we receive the route from the originating AS, we are going to get a next hop output of the originating IP address, which is going to be R33's IP. However, if we generate the address, 1.0042 is going to show up, and we do have a route to it. Notice how we have the star and the greater than sign? That's a good sign. So I'm going to go ahead and get out of the way again. Now if I jump over here to, say, 28, and I do a show IP BGP, we are going to see that 42 is reachable, and if we look at that one, we look at 1.34.42.0, it's going to say from 27, because 27, we're getting it from two different ways. 27 is inaccessible from 2043. But from 12.28.60.60, it's accessible. We do have a route to that one. And the reason why is R28 doesn't know how to reach 27. So we'll have to fix that as well. Okay, so now that I've shown you both ways to advertise a route, let's go ahead and finish out doing the peerings. So I'm going to do one more peering. I'm going to do a peering on R29. So on R29, I'm going to go to router BGP 2. Neighbor is going to be 2.22.29.22. Remote AS is going to be, and what AS did I give this guy? I forgot. Did I give him an AS number? I have not. We'll give him 65,003. This will be 65,001 if we decide to do any route advertisement, which we will. 65,002. So that's what we'll. 65,003. That's what we're going to give them. So 65003. So I'm going to go over here to 22. Bring him online. So on this guy, we're going to go to router BGP 65003. Type in neighbor, and this guy's a little bit more involved. This guy's got a CCNP, so he knows better. So no BGP default IPv4. We're going to say neighbor of 2.22.29.29, remote AS of 2, address family IPv4 unicast, and then we're going to activate this, and we're going to say network of 2.22.29.0 mask /24. Okay, now that that's done, let's go take a look at 27. Where did 27 go? 27's right there. How that happens, I don't know. Alright, so now if we hit the up arrow, 27 hasn't come across yet. Let's look at 29, make sure that the interface is actually configured correctly. It is. Do ping 2.22.29.22. Perfect. And did I configure it correctly? 22. Do show IP interface brief. $229. Why is that not coming online? Do show run section BGP. Gig 3, let's just make sure 27 is configured correctly on that interface. Show IP interface, I'm sorry, 29. 29 on 2.3 is 2.22.29.29. Do show run interface gig 0/3. Okay, he's there, and I can ping it, which is surprising. Do show run section BGP. Oh, did I? Oh, that's right. Okay. That's my fault. I didn't activate the peering on this side. Address family IPv4, and then we're going to go neighbor of 2.22.29.22, activate. That should solve that problem. So that comes online. So now that comes online, 26, let's go to 27, hit the up arrow. We're going to go look at 28. Now we're going to have to wait a moment. So 29 should see this route come in. Do show IP BGP. So he sees the route come in. 29 sees it. Should propagate it to 61. 61 should get an update from it. Show IP BGP. We do get a propagation, but it's an invalid route. So 61 gets it, but doesn't know what to do with it. 28 is not going to get it because it's an invalid route. So we look at 61, and we look at 2.22.29, 29.0, it's inaccessible. Okay, so inaccessible routes, you won't propagate. So what I'm going to go ahead and do is on 61, I'm going to show run section BGP. I'm going to go to global config, router BGP2, address family IPv4, network of 2.21.61.0, mask /24. Okay, so now that we have that done, we've gone to all 4 of our attached devices, and we've got route advertisement going. 2 of them are propagated through provider independent routing, meaning the customer owns the address space. The other 2 are advertised via provider aggregated, meaning the provider advertises for us. So now what we have to do is go through and deal with next hop processing. So now we've got that. That's 61. Let's look at 28. Hit the up arrow. 221.61 comes across, but 222.29 is not. So we had to fix that. So let's focus on the route reflected side first. This one's actually a little easier to understand. So what I'm going to go do is anytime you have eBGP peerings to the outside world, there's one thing you have to, especially when it's a route reflector client, route reflectors themselves have this implicit learn the route regardless mentality. So what ends up happening is on a route reflector client, you'll receive the route on the client will propagate. But if we look at 61, excuse me. If we look at 61 and we jump out of global config, do a show BGP IPv4 unicast. It doesn't know what to do with this. It doesn't know this IP address. It doesn't know how to get there. So there's two ways that we can solve this. The first way is to go on the peering from 29 to 61 on the route reflector client peering and tell 61 to, well, tell any other router the comment is going to be next hop self. So instead of using 222.29.22, use 2.0.0.29. So use a route that I actually have locally. The other way to do that is to actually go into the IGP, because right now if we do a show IP route, we don't have a 229.29 route in our routing table, so therefore it can't recurse to it. So what we would end up having to do is go into eIGRP. I'm going to show you both ways. Go into eIGRP, because if I look at show BGP IPv4 unicast, we're going to see the same thing for anything that's coming from 27. So if I look at 1.34.42.0, we're going to get the exact same thing. So on 29, I'm going to show you guys how to do the next hop self command. I'm going to do that to both 43 and to 61, because if I look at 43, I do a show BGP IPv4 unicast, we're going to get the same thing. You know, we don't know what to do with this. It says inaccessible. So I'm going to show you guys how to fix it both ways. So the first thing I'm going to do is on 29, I'm going to do a do show run section BGP. And on the peerings to, this is going to be underneath the address family config. So underneath BGP2, underneath the address family for 43, I'm going to type in next hop self. Okay, and I'll do the same thing for 61, next hop self. Now if I go back to 61 and I hit the up arrow, it's going to take a moment for it to happen. And what you can do on 29 in order to make this process happen faster is to do a clear IPBGP star soft. That's going to do a soft refresh. So if I go back to 61, hit the up arrow, all of a sudden now he's going to have the route in the routing table where he's got to go. So if I go back over here to do this prefix to 2.29.22.29.0, it knows how to get there. Receive from route reflector client. Right there. So that's going to be how that comes into play. Now the next piece is going to be on XR43. If we look at, hit the up arrow again, it clears it up when you have a recursable route, right? Now we go back to 61 real quick. If I do a show IP route, you're going to see 222.29 show up in the routing table as a BGP route because now it's recursable. It can find it. If I go to XR43 for something, what will end up happening is I will need to go for routes going to 28, because remember 28 doesn't have some of the information, right? It doesn't know how to get. If I go to 1.26.33.0, from 27, which is connected to 43, it's inaccessible. It doesn't know how to get there. So what I can do on XR43 is I can go to global config, and now this is running eIGRP. What I can do is router eIGRP or show run pipe begin router eIGRP. So we're running eIGRP 2, and then underneath address family I can just do interface, or actually it's address family IPv4, and then underneath interface gig 0000002 I can enable eIGRP here, but then by doing gig 002 I'm enabling eIGRP on that interface, but I also need to put in here as a passive interface. So I'll go ahead and I'll say commit. That'll get committed. Now I'll go back over to 28. I hit the up arrow a couple times, and if I do a show IP route, we'll start to see this 12.27.43 will show up in the routing table. And if I go back over here to show this route, now you can see that the route, it has a route to it, because now it knows how to reach 12.27.43. And that's where the caveat comes into play. Now, that is it's a pretty straightforward process when you think about it. So there's again, just to recap that, there's two different ways to do it. You have you can do next hop self. Next hop self, it's slower because you're waiting for a link failure and the route to go away and all that type of stuff. Where advertising the local link into eIGRP, but putting it as a passive interface, meaning that you've advertised the prefix into the routing protocol, but you're not allowing that particular interface to form an eIGRP adjacency on the other end. So that's the caveat. So now that we've gone over those two, and we're in good shape there, the next thing we would want to go do, and if I go over here to, that's 20, if I go to 61, I hit the up arrow, show BGP for all of those routes, I'm going to start to see stuff come through. Now 27, even though the next hop is a public IP, if I do a show IP route, we should see that one route coming through, which we do, 126.40.33 and 134.42. They're both iBGP peers, but I have them. They're BGP learned routes. 222.29 is coming through as well. So far so good. So let's go over to 26 and look there. Do I have everything that I need there done? So let's do a show BGP IPv4 unicast. Verify the BGP table first before you try to go verify the routing table. So if we look at this, we see 229.29 coming through, and so I see those. If I say 2.21.61.0, that looks good. And if I say, what about 222.29/24, that looks good. Now, why am I having less problems with this one? Well, the simple answer is because it's a full mesh, right? Anytime you're doing a full mesh, the route propagation automatically happens. You know who's connected to who and how, all that type of stuff. Now let's look at 60 and do a show BGP IPv4 unicast. That's looking pretty good. I'm seeing asterisk or star greater than sign for everything coming across. Show IP route. I'm seeing a couple BGP routes. I'm seeing 221.61. I'm seeing 222.29. I see 126.33, and I see one, which is that local connected. I see, but I don't see 134. Oh yeah, I do right here. It's another BGP route. Okay, now that I see that, let's go over here to 33. Let's see what 33 sees. Show IP route. So I see a handful of subnets. So I see 134.42 right there, and I see 221.61, and I see 222.29. Now let's go over to 22. Show IP route. Same thing. I see 126.33, 134.42, and then I see 221.61. Now the question, the last question I have for you guys is this: what will I see on 34? What will I see on 34 and what will I see on 21? Well, let's go find out. So let's go to 21 and let's go to 34. Okay, 34 should come back over here a little bit. Perfect. 33 should be by 34. Okay, so if I go to 21, 21's configured. So we'll do a show IP route. 21's running RIP internally, right? But we have a default route to 221.61.61. So 21 should be okay. What about 34? 34 we haven't configured yet. So we have a couple different options. So right now we're at that point where we could do a default information originate through BGP downstream to a neighbor, which is actually what I'm going to do versus a static route, because you guys have already seen that. So that's essentially what I'm going to go do. I'm going to go configure this interface. Whoops. I'm going to configure this interface 134.42 to connect to XR42, and then on XR42 I'm going to do on this neighbor, I'm going to do a default information originate and propagate the route. And I'll show you guys how to do that. So we'll type in host name is going to be R34. The interface gig 0/1, IP address here will be 1.34.42.34/24 mask. I'm going to say no shut, and I'm going to save that config. Okay, now that that's up and running, which is a good sign, I'm going to go over to XR42, say Rob and Cisco. Now, there's a caveat here. We're not running BGP on this link right here. So if I show run router BGP, I can do a default information originate underneath the address family. So if I go underneath here and type in router BGP 1 and then address family IPv4 unicast. Oh, it's not going to let me do it here. Actually, I could probably do a network quad 0. Network 0.0.0.0/0. That should let me do what I'm hoping it will do. So do show IP BGP. I don't know if it's going to let me do that or not. Now, maybe without a default route in the routing table already. Yeah, I don't think so. So what I'm going to do, just to make this a little bit more compelling, is on 27, I'm going to create a null route. And what a null route is going to do, essentially, is I'm going to create a default route that will be reachable through the internet. So it's going to be a throwaway route. When you hear the term null, N-U-L-L, for a default route, it's just a throwaway route. So we'll create it. So the command will be IP route 0.0.0.0 to null 0. Okay, that's a null route. So you can enter that into the routing table, and then what will end up happening is if I do show IP BGP, it's not going to show up here right away. But what I can do underneath router BGP 1, underneath address family, I actually do show, I should be able to do a default dash information originate and do show IP BGP. Because if I do show IP route, there is a default route in the routing table. 126.27. Okay, so do show run pipe include IP route. Let me take this default out. I forgot that was in there. Okay, so do show IP route. We have a null route in the routing table. Do show IP BGP. Do show run section BGP. Default information originate. So it's in there. I might have to do a network statement to trigger it. But what should end up happening is 33 should end up getting a default route through that. And I think I'm going to have to go to 27. Router BGP 1 network of... Actually, I should just be able to do network there. There we go. So do show IP route, or I'm sorry, do show IP BGP. There's the default route. Now 33 should get that, and it does, a BGP default route. 33 gets it, and on 34, since I don't already have a default route, what I will have to do is IP route 0.0.0.0, 0.0.0.0 to 1.34.42.42, and I'll go ahead and save that. So there's that piece. Okay, so now that that's done, let's go over to 28, make sure that that route got propagated. So show BGP IPv4 unicast. We're getting a default route from 60, which is what I want to see. And then 29 should see it as well. Show IP route. I see a default route coming through. And 22 should be getting that as well. However, there's a static default route. Okay, there's a static default pointing to 29, but if I show BGP IPv4 unicast, I am getting a default route. There's a static one there. There's not a way to really show this if the route isn't already, if you're receiving a default route via BGP, what you can do is on 29, you can do a show BGP IPv4 unicast. Then you can go up here to neighbor 1227.43.20, I'm sorry, 229.22. And you can type in here advertised routes. And by doing that, you can prove that you are advertising a default route outbound. Even though he's got a static route, there is a default route available. So that's basically how that would come into play. Now the question is, on 33, can I ping 22? So can I ping 2.22.29.22? So I can't ping outbound. Why am I not able to ping outbound? Let's do a trace route to 2.22.29.22 numerically. How far can we get? We get to 43. 43, well, it does actually get there. Now the question is, why am I having a hard time? Oh, okay. So it is able to get there. What about pinging 2.21.61.21? Yeah, let's try to ping 21. 21 goes through just as you would expect it to. Perfect. Now the question is, on 21, can I ping 1.34.42.34? And I can. Trace route to 1.34.42.34 numerically, and I get there all day long. Now we don't see it. We don't see a AS path here, but that's because 21 is not running BGP. 21 has just got a static route. But if I go to 22 and I do a trace route to 1.26.33.33 numerically, 29 gets there. Oh, we have a, okay, so this is why we're having a hard time with that. So we get to 29, but then we go to 27. So there's a problem in this provider, and this is what we need to go figure out. So let's go see what the deal is. 29, resolution loop formed by routes and rips. So show IP route. So what's going to end up happening is we need to make sure every router in the entire environment knows about all of these additional routes. So if we go to, and we can recurse to them. So BGP flapped right here. I don't know if you noticed that before, but BGP flapped with that particular case for XR43. So 43, let's see what the deal is. Show BGP IPv4 unicast. We have all the routes in the BGP table. Show IP route. And we have the routes here. So somewhere between 43 and 29, there's a problem. What about 28? What does 28 see? Double that. Okay, so that cleaned it up a little bit. So show IP route. So that seems to be okay. Now, my opinion on this whole thing, even though I demoed how XR43 can do eIGRP, can advertise this link into eIGRP and then set the passive interface, in my opinion, that's not a clean way to doing things. So it's more or less me showing you what's possible versus what is more best practice. Best practice is not that at all. Best practice, in this particular case, is going to 43, show run router eIGRP, and we're going to go underneath router eIGRP2, address family IPv4, and I'm going to say no passive interface, or no this interface. I'm going to exit out of there twice. I'm going to do show run pipe begin router BGP. And what I'm going to do is I'm going to set the next hop self router BGP underneath the address family here. I'm going to do a command of next hop self. Next hop self. And I'm going to commit that command. So if I go back to 28, I'm going to see 43 is my next hop and not the public address range. I go over to 61. Let's actually look at 29. 29 seems to be where the problem occurred. So show IP route, we're going to see 43 as where it's got to go. Let's see if that's any better. So let's go back to 21. Was it 21? 22, sorry. 22. Go back to 22. We're going to ping 1.26.33.33. That pinged a lot cleaner. Let's do a trace route. That's a lot smoother. But here you do see the AS hops in the output because there's BGP involved here. So that is why I am not a fan of doing you can advertise the locally connected subnet into your IGP versus the next hop self command. It's a lot cleaner in my opinion, and you don't run into problems where you're not able to figure out where the route is. The whole purpose of doing this advertisement into IGP is so that 29 would be able to see everything that's in its AS. It would know how to route to that. As long as it's got a route to it, you're in good shape, or supposedly. So if I was to do a trace route again, let's see if we're running into the same problem. Okay, so we have a deeper seated issue here. Let's see if it's a 43 issue. Control-Shift-6 to cancel out show IP route. Okay, so it seems like it's... Oh, so things just reset. No, it's BGP. BGP seems clean. That's 22. 29 is where I need to look. Okay, so BGP is having an issue with 43. So XR43 is our problem. So show BGP IPv4 unicast. Show IP route. You know what? No, that's incorrect. 29 is our problem because 29 keeps flapping with BGP. So we might have some inconsistency issues there. So I might have to reload this box, shut it down, power it back on, whatever the case might be. I'm going to save the config while we're at it. But these are the type of situations that I wanted to discuss and walk through and how it's going to come into play. Now there's a question. You mentioned running eBGP everywhere. Is it still a good idea to run an IGP as the underlay for your BGP deployment? And the answer to that question is, it is, but there's nothing stopping you from giving every one of your routers their own autonomous system number and then doing a full mesh of eBGP peers in your point-to-point connections. Because it wouldn't really make sense to do an eBGP peering from 43 to 61 because they're not directly connected to each other. So it would make more sense to do this because that would be the data path. It makes more sense to do the data path peerings than it does to try to do control plane peering. It's like 42 to 27 or 26 to 60 because they're not in the data path. They're not connected to each other. So there are cases where it makes more sense to do so. So if I go back to 22 and I try to do the same trace route again, it's consistent. As long as 29 is consistent, oh, it keeps flapping. Why does it keep flapping? Okay, so we might have a flap. We might have to dig into this a little bit deeper and figure out what's going on from 12, 28. Oh, wait, hold on a second. So wait a minute, before it was 43, now it's 60. So there's a problem somewhere in the network. Oh, it's flapping. It's flapping between the two. That's what we're having a problem with. So it's not stable. So let's dig into this a little bit. So we're flapping between the two. Why are we flapping? What is the deal here? 28 is not a route reflector. 28 is a client. 43 is a route reflector. Let's look at 28 here. So it's like 28, show BGP IPv4 unicast summary. It's like the peerings are up in stable in that respect. We're getting a default route from 43 and from 60. Let's look at 29 again. Okay, so 60. Let me debug BGP IPv4 unicast updates. I wonder why it's giving us a hard time. So far it's stable there. There's a question. Oh, here we go. Received update 61. Revised routing. What's it saying here? Or internal local preference metric 0 originator 28 cluster ID 61 merge path 1 AS path. So we have a flapping route for those two subnets. The question is why? What is 61? What's going on in 61? Show BGP IPv4 unicast summary. So the peerings are both up. The route looks okay. But 29 is getting inconsistent routes. Let's debug 28 as well. Debug BGP IPv4 unicast updates. Now this is a virtual lab, so I'm not taking 100% of this to be 100% gospel. Oh. Okay, what do we got going on here? So, we have a received about originator is us. Okay, that makes sense. Receive update, quad 0 denied due to originator is us. Because we're receiving now from 60. Therefore, we're not going to go ahead and push. '29 is getting the routing update, but 28 is denied due to originator is us. Yeah, that makes sense though. We're getting the route in. We're getting the route in twice. And that might be because of the fact that we're route reflector clients. It might make more sense to take one of the route reflector out of the mix, but I don't think that's the problem. Because when I see this is what I'm seeing. This is why I have the thought process that I do. If I look at this output right here, right? What I want to see now, let me go move this up so it's easier to see. What I'm waiting for is a new output where I have the alternative paths. Because what I want to do is I want to identify why we're running into this issue. Okay, there it is, and I can do this. Okay. So what I'm seeing here is, okay, what I should do, I'm getting two different updates, but the one from 40, the one from both in there. Now I want to see which one it's keeping and which one it's throwing away. Okay. So it's keeping 43, so 61. So this one's stable. But we're getting a, so here's what I would do. Essentially what I'm seeing on 28 is this. I'm seeing competing cluster IDs, cluster lists. I'm seeing cluster list 61. Yep, I'm seeing cluster list. So we see cluster list is 61. Are we not? Show run section BGP. And both of them should be route reflector client. So let's check 43. Show run router BGP. Oh, maybe that's part of the problem. Next, well, maybe that doesn't make sense. But we're not doing that on 61. Show run section BGP. We're doing route reflector to 28, 29, and 43. '28 is constantly getting an up 61 a cluster list. So let me do a little bit of digging on this, and then I'll pause the video, do a little bit of digging, and I'll bring you guys back in. Okay, I am digging into a little bit. I think I'm right. I think the cluster list is the same thing, so we need to treat it's like kicking back the route. So what I'm going to do is on 43, I should be able to set 43 and underneath here, address family, IPv4 unicast. Let's see here. Where does that command sit? BGP cluster ID is going to be 2.0.0.61. I'll commit that. Because right now when I'm getting the routes in from 28, I'm not seeing a, because I wasn't seeing a, see if that doesn't, wasn't seeing a cluster list. So does that get us stable again? Show IP route. Because we really want the route. It doesn't really matter where we get the route to come from. Let's see if that doesn't stabilize us. Even though 28 is still squawking over here due to originator as us. Show IP route. Yeah, so I expect that to happen. 29. Yeah, see, that didn't fix it. 28. I don't see the cluster list. You know what I'm going to do? I'm going to take 43 out as a route reflector and see if that doesn't simplify what we're doing here. I had it in there just to show you what the config was. I really didn't have a real purpose for it. So let's go back to 43 and we'll do a do show run pipe router BGP, and then underneath here I'm going to say no route reflector client. Yeah, that should be fine because I'm not trying to. I'll commit that. So when we get the updates in, it'll bring the peers down, then it'll bring the peers back up because 61 is the only route reflector we really need. Hopefully 28 will settle down then. Because what we'll end up getting, what I'm looking for here is received update denied due to originator is us. But then that triggers 29 to bounce the routes. Then we update, and then yeah, it's still triggering. I'm not exactly sure why this is happening. .28 is triggering. We're learning the default route in. Here we're receiving the route. We're getting basically we're getting a control plane route back, and we're dropping it, which is triggering 29 to drop the route. Then it reinstalls it again because 28 is propagating it. Then it trips out and says, well, which that doesn't actually, it's kind of weird. I'm not exactly sure why that's happening. Show run section BGP. Let me take this peering down. Remove him. Take the peering out. Because I really don't need to have 29 or show run section BGP. I really only need to be peered with 43 or with 61. So I'm going to take this peering out. That will maybe settle things down. Because I really only want to be learning routes from 61. 61 is the route reflector. 29 gets routes, 28 gets routes, 43 gets routes. They propagate to 61. 61 then will reflect them where they need to be. Why is that tripping out still? Local router is the originator. The local router is not the originator. 43. Do show run pipe begin router BGP. I'm going to take these two peerings out, 28 and 29. They don't need to be there. But it still doesn't explain why I'm still getting these 2001. Hold on, let me undebug. Undebug all. Local router. Say local router is the originator discard update. $60 is propagating a route. Show BGP, IPv4. Show IPBGP. We're getting those in. 28 gets it in as well. Show IPBGP. We get 26, and then 43 gets show BGP. Can I do a show IPBGP? I can. So we're getting 126.33 from the next hop, and 28 is doing the same thing. They both have the same AS path length. So 61 gets that into the show IPBGP. We get this path is shorter. I'm sorry. They're both equal cost routes. One is choosing, they're both choosing to go through 60, or I'm sorry, to 28. Next hop is, oh, I see what the problem is. I didn't set the next hop on 28. Let me go to 28. And let me turn that debug back on. If we do show run section BGP, I don't have the next hop self turned on. That's what the problem is. I bet you any money. Let me debug BGP IPv4 unicast updates. So I'm going to go to global config. I'll go to here and say next hop self. So it's not a matter of reachability per se, but if I look back over here, whoops, I'm going to be looking at, so let me go to 28 and do a clear IPBGP star soft. And then we're going to go back to 61. We'll hit the up arrow. Now the stuff will come in as that. Hopefully that might settle things down. And 29 won't be freaking out as much. Show IP route. Yeah, because it'll know where to send it. I didn't even realize that. I was like looking at the dude originator as us, and I'm like, well, why is it not coming through? So this is why you had to be thorough. So yes, I was demoing things, but I wasn't being thorough and double checking in the configuration. So it seems like that might have solved our problem, because now we're at a minute 13. And 29 is not doing any more processing. If I go back to 22 and I do a trace or ping to 1.26.33.33, now it's going to make me a liar, huh? Trace 1.26.33.33 numerically. 29, gets to 29. 29 doesn't know what to do with it. $29 says go to 43. $43 says what? Show IP route. Yeah, it says go over to 27. 29, and so we've actually broken connectivity. So 29 gets it. Show IP route to 2.0.0.43 via eIGRP2. So we have a recursion to that. But 126, what is 33 getting? Show IP route. Ping 2.22.29.22. Okay, so now we have other problems. So trace route to the same address numerically. 126.27. So 27 says I don't know what to do with that. Show IP route. He doesn't have a route to, he does have a route to 229. But, 2, 12, 20, 27. 27. Why am I going that way? Coming down here to 60? And 21, interesting, they're going in opposite ways. So, even though 28's settled now, because we changed the next top value, the trace route from 33 gets to 27. 27 takes me to 12, 28, 60, 28. Show IP route to 12.28.60.28. Subnet not in table. That's what the problem is. So I need to set. So this is a particular case, even though you're doing a full mesh, this is one of those situations where you need to set, it doesn't know how to reach it, is what the issue is. So same thing with this address right here, 12, 27, 43, 43. It's going to know connected, but it doesn't know how to reach this one. So this is one of those situations where it's like, okay, well, maybe it makes sense to do OSPF, enable it here on the full mesh. So what I would do is I'd go to 60, show IP BGP there. Let's go to 27. Let's do a show IP BGP, and it does have a route to it, right? If we do a 12.28.60.28, I'm sorry, 2.22.29.0/24. I do have a route to it via 60, but for whatever reason, if you look at 27 in the routing table, in order to get there, we have to go to 28, and it doesn't know how to get there. So we need to set on that peering on 60, show run pipe section BGP on the peering to 27. We will do, it's actually kind of a roundabout way of doing it, but it gets the job done. We'll do next top self, and then we'll do clear IPBGP star soft. We'll go back over here to 27. We'll show IP route, and now 60 will be the route in the routing table. And if I go back over here to 33, I'm able to reach it. And 22 should be able to ping as well. And trace end to end. So that was the problem. Same thing if we were to go to 60 and do show IP route for 21. It's telling me to go to 12. It's telling me to go 1260.27. Wait for 221. So it's going this. It's going this path. Everything wants me to go this way, which is fine. That gets the job done. So 27 sees the path. So the question is, if there's an issue between 60 and 28, so we'll go to 60, and we're going to go to exit out of there. Do show run section BGP. We're going to take down this peering. I'm going to go to this peering right here. Neighbor here, I'm going to say shut down. I'm going to take the BGP peering itself down, which should administratively remove any routes in the routing table. So do show IP BGP. So now we should shoot our routes up to, so 60 is going to go, next hop is 1227.43. Notice that, in 1226. So now if we go to 27, show IP route, we should go via 1227.43.43. On 27, if I go back to 60, it's going that path, but if I do show IP route for that subnet 221, it doesn't know how to get there. Right? It's not going to have a path. If I do show IP route for 12.27.43.43, no route in the routing table. So on 27, show run section BGP, what I'll have to do is on the peering to 60, I will have to set next hop self. So, and I'll do a clear IP BGP star soft. So I'm going to go to 60. 60 will then have a route to 27 now, before it didn't. So now if I go back over here to 33 and I do a ping to 2.21.61.21 and trace to that address, Control Shift 6 to cancel that, and we'll do a numeric, it gets to there all day long. Now if I bring up 60 again on that peering, if I say underneath this guy here and I go to no neighbor 12.28.60.28 shutdown, that shuts down that enables the peering, brings the peering back up, and then if I do a show IP route, I am now going to go 12.28.60.28. 27 will update some routes, and we're going to go by a 60 for both paths. 12.27.43 will go 2.21.61. And you might say, well, how come you're going via one and not the other? And it's kind of unusual because here you're doing hot potato routing. You're routing at your locally connected subnet, but you're doing cold potato routing here. So we could adjust this to make them both, but you would think if I'm on 27, I would go this path, but from an AES path perspective, show BGP, oh sorry, the AES path is going to be longer one way or the other. So show IP BGP, it's actually, from an AES path perspective, it's, let's see here. So I'm only getting this one from this one. But from an AES path perspective, oh, you know why? Because on 60 is a new peering, 43 was already up. That's why. So if I look at that peering, the peering, it's not going to give you a timer per se, but it would give you, the longer the AES, or the longer the peering has been up, the more preferred it is if they're the same AES path. So this guy here was already up, this one was down, so this is why it's choosing this. And if we look at 28, If we look at 27 again, I'm sorry, 60. If we look at 60 again, right, we're taking the path for both via 28, which is a little unorthodox, because you would think from 60 it would either go up to 27 and over here, but from an AS path it's not doing that. Now, BGP doesn't look at hop count, it looks at AS path count. So that's one thing to keep in the back of your mind, is 60 is looking at it from that perspective. 27 is sending both routes. If I do show IP BGP, BGP on 27 is sending traffic to get to 220.229 via 60, and to get to 221.61 it's going to go 12.27.43.43. And the reason why it's doing this via this path in this particular case is because that's a shorter AS path. It does have 221.61 via 60, but that AS path is 2. This AS path is 3. So AS path, it's shorter this one. That's why that's happening. 222.29 is going, so there's only one route to it from 60. I'm not exactly sure why. 29 is propagating it. 43 should be learning it. Has 43 not got that route? I'm curious now. Show IP BGP. 221.61. Yeah. It's receiving it. 28 should be as well. Show IP BGP. 61. And they're both, it's both internal route. So I'm not exactly sure why it's doing show IP BGP for. It doesn't always make sense, I'll be honest with you. So metric is 16,000. And on this side here, on 28, show IP BGP for 221.61. 28.48. This might be the determining factor. It's the lowest metric to the router ID. But 43, if I do a show IP route, 29 to get to 61, gig 00, gig 01. So it's load balancing that. 28 is probably doing the same thing. Show IP route. 61. Yeah, because we're directly connected to it. So I'm not really going to dig too much deeper into it, why we're seeing the traffic pattern we do. At a high level, it's going the direction it needs to. So if I go back to 33 and I do a trace route to 21, I get there. Now remember, a 21 subnet is actually being advertised by 61, or if I was a trace route to 2.22.29.22, numerically, that's a BGP route. So it's going to go via 29. So it's going 43, where this one here is going 60 to 28. So it's kind of a weird paradigm where I'm advertising this one locally, but I'm advertising this one remotely. So it's weird. Oh, you know, well, AS path length does have something to do with it. Show IP BGP. So they're both going to go out to the same 26. 26 sees show IP BGP. 26, 21 sees it via both paths. But it's choosing to go via that one. Why is it showing show IP BGP? Why is it showing to go via that? Local preference is the same. Metric is the same. Best. Why is it doing best path? But why? Why is it doing that? So normally in a situation like this, I would multipath. I would do route reflection. I would enable multipathing, and go from there. it would give me a little bit more flexibility, but wait a minute, lower router ID, maybe that's what it is. Lower router ID is winning. Hold on a second. 27, show IP interface brief. Oh, the router ID. Oh, you know what? I never set the router ID. Do show run type section BGP. That might have something to do with it. Let me go ahead and router BGP 1 BGP router ID is going to be 1.0.0.27. So let me go over to 26. Interesting. Did it take the route out? The route's up. Show IP BGP summary. We're not even getting anything from 27. That might take it a moment for it to propagate. Show IP BGP. Oh, it's still doing best path selection. That's what it is. I'm going to save the config. It's still doing best path selection. So whenever you see this right here, this means if you've gotten everything configured and you just bounce the router ID, then it's doing best path selection. And once it does best path selection, then it'll inject the routes, and there it goes. So there. Okay, now it's sending that one for, okay, so that still makes sense. 26. $21.61. Okay, now it's sending it. Okay, there we go. So in this case here, it's going based off lower. So you got two routes, and now it's sending it via lower router ID. Right? Well, we'll talk more about the best path selection algorithm and how that works. But that makes more sense. So you're sending, I was like, that doesn't make any sense. Why is that happening? So 26 is going to send traffic to 21 via, 21 is going to go, 2161 is going to hit 27 is going to go via that. Now let's go check here. And here it's going to send it via 43, and it's going to send 222.29 via 60. Which still doesn't make a lot of sense, because well, yes and no. Yes, it does. Actually, it makes total sense. The way that it's been advertised, I take that back. So this has got a shorter AS path length, and this is a longer AS path. So it's learning both routes from the same two different devices, but it's choosing this path. In this case here, the next top. Let's look at 221.61. Here, and this is external, right? So you're going to do hot potato versus cold potato, and again, this is a shorter AS path too. So you've got, well, no, I'm sorry, they're the same AS path length for both. One is an external best path, one is internal, and you're always going to choose to take your eBGP path versus your IBGP path. Unless you do something else, like go on to R60 and do a local preference for any routes learned this way, or you prefer it, and I'm not going to get into best path selection right now, but that's why you're seeing what you're seeing. So even though the router ID is technically higher, it's an external route. So you're doing hot potato routing. We're getting out of the AS as quickly as we can, even though 21 is technically located over here. It's going to send it via 43. 43 will route it through 28 to 61 or 29 to 61 and go that route. That is why we're seeing what we're seeing. So now that we have reachability, and we'll just double check one more time before we wrap up that everything is working the way we expect it to. So 33 should be able to ping 2.22.29.22 and should be able to ping, get out of the way, 2.22 2.21.61.21, and I can do that, which is what I want, and I should, not really relevant, but I should be able to ping 1.34.42.34. So this one here is 134.40. Oh, okay. It's like, why is that not working? I got more troubleshooting to do. All right, so if I can ping those, let me go over here to 22 real quick. Ping 2.21.61.21. Perfect. So I can ping everything. All right, an hour and a half later, I'm gonna see if I can't edit some of that out, but it was a lot of just making sure things were working the way we expected to, and then digging into the why it's not. So at the end of the day, that is what routing is all about, is understanding what's going on. Now, and I'm going to continue to try to go through that, and this will be a longer video, but it's going to be next hop recursion, and I expected it to be a longer video. So if you guys have any questions, comments, concerns, feedback, drop that sucker in the comment section below. If you haven't already done so, please like, share, and subscribe, and I'll catch all of you fine people in the next video.